Stephen Hawking was one of the greatest minds of physics and cosmology. His recent passing is believed to have left a void in the scientific community. Many times, however, the fact that a man with a lifetime disability made genius contributions to the understanding of a universe overlooks the actual genius ideas that came from him. In his lifetime, Stephen Hawking made several predictions based on his intuitions, and several times he was proved wrong too, not only by others but also by himself. Well, that is what science is all about. Aristotle and Ptolemy were wrong about Earth being the center of the universe, yet we can't deny the fact that they were great visionaries in their times, as was Stephen Hawking, for they all were icons of curiosity. No matter what helped his rise to fame, Professor Hawking was undeniably an inspiration to many. But what exactly were his contributions to science? Let's start with a brief history of time. In the international best-selling book, Hawking discussed in detail the multiple theories that try and explain the various aspects of our universe, right from quantum theory, which focuses on the tiniest things like atoms and particles within, to Einstein's general theory of relativity, which talks about matter in a cosmic scale like stars and galaxies. One would argue that the two are polar opposites. From the brief history of time, you can understand that Hawking's paradoxical idea was to unite all theories of science, physics, mathematics, and anything else that we have managed to gain knowledge of, to form one fundamentally unified theory of the universe, one theory of everything. This is considered almost impossible. Even Hawking himself kinda admitted to it when he said, if there really is a complete unified theory, it would also presumably determine our actions. And so, the theory itself would determine the outcome of our search for it. What he meant was that there is no guarantee that such a theory would determine that we reach the right conclusions or any conclusion at all. However, he believed that natural selection allowed certain organisms to make the right conclusions and survive, and thus he continued on his quest for a unified theory. No, Stephen Hawking did not propound the theory of everything, but he came close and did something that nobody else had managed to do hitherto. He brought together quantum mechanics and general relativity to present some groundbreaking theories about black holes. If you believe in the Big Bang theory, you would agree that at the beginning of the beginning, the universe was infinitely small and concentrated, a singularity. Then the Big Bang happened, marking the beginning of time, and the universe has been expanding ever since. Billions of galaxies and stars and planets were born, and billions of them have died. When a massive star, much bigger than our own sun, dies, it collapses into itself, forming a black hole. The entire mass of the star is then packed into a much smaller sphere, making the black hole very tiny relative to the size of its star and thereby extremely dense. Because of this, the gravitational pull of a black hole is so strong that even light cannot escape it. Hence, it appears black. Albert Einstein's general theory of relativity indicated the presence of black holes, yet he did not believe that their existence could be a real possibility. Since then, several scientists have taken interest in exploring black holes, and Stephen Hawking was one of the notable ones. We have now observed that black holes not only exist, but supermassive black holes that are as massive as several billion suns dominate the galaxies across our universe. The only way we have managed to observe a black hole is by noticing other stars in its path magically disappear, never to be seen again. But Hawking made this path-breaking prediction that black holes do emit radiation, which is called Hawking radiation. Remember, I said that nothing escapes a black hole, not even light, right? Well, it still stands true. Technically, Hawking radiation does not come from within the black hole. This is where quantum theory comes in. During Big Bang, the universe was filled with enormous energy that led to the creation of matter and antimatter. For some reason, we ended up with more matter than antimatter, but the particles of matter and the antiparticles of antimatter have this mind-boggling property of constantly being created out of nothing and then almost immediately annihilating each other because they are oppositely charged. When this cosmic wonder happens near the event horizon of a black hole, there are chances that they get separated and one gets sucked into the black hole while the other particle or antiparticle moves away from the black hole. This energy radiation or Hawking radiation, which exists theoretically, implies that the black holes aren't very black after all. This was one of his most notable works. Stephen Hawking came up with several such laws of black hole mechanics and also later disproved some of them. Throughout his life, Stephen Hawking had expressed his opinions on diverse subjects ranging from string theory and multiverse to alien life and artificial intelligence, even the existence of God. His thoughts and ideas were very fascinating, and the fact that he continued to be a patron of science against all odds is truly inspiring. His resilience will never be forgotten.